It says you have an Azure subscription that contains a virtual network named VNet1, and the virtual machine shows in the following table. So we have VNet1, and inside VNet1 we have VM1, VM2 and VM3. And VM1 is hosting HTTPS application protocol, VM2 is SMTP and VM3 is SFTP. Okay? All the virtual machines are connected to VNet1. That's fine. Now, the next part of the question says you need to ensure that application hosted on the virtual machines can be accessed from the internet. Okay? And the solution must ensure that the virtual machines share a single public IP address. What should you use? Let's move to the next question. You have an application named App1 that listens for incoming requests on a pre-configured group of 50 TCP ports and UDP ports. Okay. In question number 3, we can see you plan to implement an Azure Application Gateway that have the following configurations. Okay. It has public endpoint, which is 1. It has 1 private endpoint. Minimum instances are 1 and the maximum instances are 10. Fine. Let's move to the next question. Here in our question 4, you have an application gateway named AZ-700. Fine. That has routing rule named rule 1. We have seen in our lab as well, we have created application gateway and then created a rule 1 as well. Okay. Now the rule 1 directs traffic for www.contoso.com to a backend pool named pool 1. Okay, that's interesting. So basically rule 1 has the option to direct the traffic from www.contoso.com to pool 1. Now, pool 1 targets an Azure virtual machine scale set named VMSS1. And you deploy another virtual machine scale set named VMSS2. So let's understand this part. We have one application gateway. Inside that application gateway, we have one rule. And we have one backend pool called pool 1. And pool 1 is using virtual machine scale set 1 as its target. Fine. We also created another pool, virtual machine scale set, which is virtual machine scale set 2, VMSS2. Next question. Okay. In this question, we have a statement. In WAF v2 and standard v2, application gateway can run only in fixed capacity mode, not in auto scaling enabled mode. Hello everyone and welcome to this video of 591 Lab. I am Manny and I am thrilled to have you here. In this video, we are going to learn about Azure Application Gateway and review some questions related to AZ-700 exam. Azure Application Gateway is a key service used for load balancing and path-based routing in Azure. We are going to cover all of it in this video. Before we begin, let us introduce ourselves first. We are 591 Lab and we are top IT training and certification exam brand in China, Hong Kong, Taiwan, Singapore. Our mission here is to provide our clients with exceptional exam preparation experience for certification in Cisco, Huawei, Aruba, Juniper, Microsoft, and Azure Cloud. To know about us in detail, please visit 591lab.com. Along with this, we have a humble request to subscribe our channel, like the video, and hit the notification bell. This helps us to create more contents like this. So without spending any more time, let's have a look at the agenda for the session. Here is our agenda. First, we are going to talk about what is Application Gateway. Then we'll see what are the prerequisites to create Application Gateway and how Application Gateway works. After that, we are going to see how to create Application Gateway in Azure portal. Later on this video, we are going to review some AZ-700 exam preparation questions related to Application Gateway. So let's move to the first slide. In Azure, we have 4 types of load balancing services available. They are load balancers, Application Gateway, Traffic Manager, and Front Door. Out of these four, load balancers and application gateways are regional. This means they have the ability to load balance the traffic for resources within their region only. For example, Application Gateway in East US can do the load balancing for services in East US only. On other hand, we have Traffic Manager at Front Door, which are capable for load balancing the traffic across regions. For this session, our focus is to discuss application gateways. What is Application Gateway? It is a web traffic regional load balancer that helps to load balance the traffic for the web applications. The routing and the traffic distribution decision is based on the attributes of HTTP request like URL path or host headers. To understand them, let's have a look at the diagram. Here is our diagram. In this example, traffic for contoso.com can be routed based on incoming URL. So if the image is in the incoming URL, then you can route the traffic to a specific set of servers known as backend pool configured for images. If /video is in the URL, then traffic is routed to another pool that is optimized for video. Other than the URL or path-based routing, Application Gateway has other features like SSL offloading, web application firewall, and session affinity. Now, let's have a look at some prerequisites which are required to understand before we create Application Gateway. First prerequisite is a dedicated subnet. To deploy Application Gateway, we need a dedicated subnet where no other resources should be deployed other than the Application Gateway. So we are going to see we will have a virtual network, and inside that virtual network, we are going to create a subnet, and we are not allowed to deploy any resources like virtual machine or any other virtual machine scale sets inside that particular subnet. One subnet must be dedicated to Application Gateway. Yes, we need to understand in that subnet we can deploy more than one Application Gateway, but only Application Gateway. Second prerequisite is public IP. This is not mandatory. However, the app gateways are most suitable load balancing service to route the traffic coming from the internet to applications hosted inside Azure. This public IP is going to help us when any traffic is going to come outside the Azure organization or our organization. Then third prerequisite is backend pool. It is a group of actual server or resources where the application is actually hosted. Currently, we have virtual machines, virtual machine scale sets, app services, and on-prem servers that can be used as a backend pool. So in the backend pool, either we can host our virtual machines, virtual machine scale sets, app services, and on-prem services as well as a backend pool. So this is all about the prerequisites which we need to understand before the creation of Application Gateway. Before we learn how to create Application Gateway, let's understand how it works. To understand this, let's go to this diagram. We need to understand this diagram to understand how Application Gateway routes the traffic or how Application Gateway works. As we know, App Gateway is a web traffic load balancer. So let's understand all this flow in step by step. In step 1, a user on his laptop opens the URL of the application, for example, www.contoso.com. Now in step 2, the request reaches to front-end IP of the Application Gateway. Front-end IP could be private, public, or both. So this is the front-end IP, and it is a component inside the Application Gateway, and it could be public IP, it could be private, or it could be both. Now, if application is supposed to be accessible from the internet, then we need a public IP at the front end. If the application is only supposed to be accessible within the organization's network, then we can use private IP at the front end. Additionally, we can configure both private and public IP together at the front end to serve external and internal users both. Now, in the step 3, the request at the front end is received by a listener. The listener is the next component inside the application gateway. It is a logical entity that checks for incoming connection requests. Before you use an application gateway, you must add at least one listener. There can be multiple listeners attached to one application gateway, and each listener can receive different requests. Now, after the request is received by the listener, so the listener detects incoming requests from the clients, and the application gateway routes these requests to the members in the backend pool configured in the routing rule. So basically, listeners receive the request, then it routes to the backend pool or member of the backend pool. However, the routing rule, we have backend setting or HTTP setting, which basically defines the port and the protocol which is going to tell application request how to send the request from the listener to the backend pool. Now, so the flow request comes from the user or clients and it comes to the front end. Then it goes to listener. Listener uses the routing rule to send the traffic to backend pool by defined port and protocol at HTTP settings. So this is how the application gateway works, or the traffic moves across the application gateway. I hope this helps you to understand how it works. Now it is time to go into the Azure portal and deploy this architecture. We are going to the Azure portal and we'll see how to deploy application gateway and how to deploy image and video server pools. So this is the pretty much architecture which we are going to deploy and see in the Azure portal. So let's go there. We are in our Azure portal. Now, before we create application gateway, it is time to validate the prerequisites. The first prerequisite is to have a dedicated subnet. For that, let's go to our virtual network, and VNet1 is our virtual network. Here, we'll go to the subnet, and you can see I have already created a dedicated subnet here, App Gateway Subnet. I have not deployed or created any resource inside this subnet yet. Subnet 1 is the subnet where I am going to host my virtual machine, which are basically hosting my actual application. The second prerequisites which we need to validate is the public IP address. Since we are going to use public IP address at front end of my application gateway, so we must have a public IP address, which I have already created for this lab. So this is the public IP address. Now let's go to and validate the third prerequisites, which is backend pool. So here as a backend pool, we are going to use the virtual machines, and virtual machines are basically our backend pool where we have our hosted application. If I click on this virtual machine, which I have already created, image virtual machine is my virtual machine where I'm going to host my application, image application, and in the video application or the video virtual machine, I am going to host my video application. To host the application, we need to log into these machines one by one and run the code of our application. So let's go and log into these machines, which I have already done. So I'll just go and look at the window. So this should be our image VM. However, let's confirm that. Yes, we are inside our image virtual machine. We are going to use PowerShell to host our application. So we have a code to host our application. Let's open the PowerShell and let me copy the code for my application. So this application, this is the code for the application. Basically, whenever we are going to host any application inside Windows operating system, we need to first install IIS. So this code is going to install IIS on this machine and then do some configurations related to my web applications. So let's go and execute it. So if I'll go and execute it, okay, now it's executed. So my application is hosted inside my image application or image VM. Let's go and do the same thing inside video virtual machine. We are in our virtual machine, which is a video VM. So let's validate it first again. Yes, we are in video VM. Let's open PowerShell. And here is our code. Again, we are installing IIS and doing some configurations related to my video web app. So run this. And this is completed also. Now go back to the Azure portal. So now we have hosted one application inside the image virtual machine and one application inside video virtual machine. Let's go and access them. So this is the public IP address, and I'm just going to open a new browser and I'm just going to paste here, and let's see what happens. So the moment I enter only the public IP address of my virtual machine or image virtual machine, I can see the default page is loading. This basically indicates the IIS is already installed on this machine. Let's go and try to access our application. So for our application, we have used this images and my images.html. So now you can see image web app hello world. This is the web page for my image app. So this is basically going back to my image VM. Now let's do the same validation with video app. Open a new and go to here. The default page is loading, which means IIS is installed, and it's time to use the videos. This is the path video / and you can see here video web app hello world. This is the web page for video app. So till now, what we have validated, we have a dedicated subnet, we have a public IP, and we have two virtual machines where we have hosted our application. Now it is time to create a application gateway, and then we'll see what is the difference happens after creation of virtual application gateway. Let's go to home, and to create an application gateway, look at here. Okay, one more point where I would like to draw your attention is the load balancing services. In the beginning of the video, I told you in Azure we have 4 load balancing services: application gateway, load balancer, front end, and traffic manager, where load balancer and application gateway are the regional load balancer. So we are inside the application gateway and we are going to create application gateway. Hit on create application gateway. We are going to use the same resource group. Here we need to provide the name. So I'm just using a simple name, which is app gateway 1. We can provide it anything. It's better to put it like this. Standard v2. Okay, here few things we need to understand: standard and standard v2, WAF and WAF v2. So these are 4 tiers provided by Microsoft for application gateway. So when we choose standard v2 or WAF v2, we are getting the option of auto scaling. When we choose only standard without any version 2, you can see the option to auto scale is gone. So standard v2. Now WAF is basically a web application firewall. So if your application require an extra layer of security, then you can use the WAF v2 or WAF as well. So for this lab, we are going with the standard v2, and it says enable auto scaling. Yes. Minimum instance we need 2, and the maximum instance we need 2. Availability on, let's it set to none. We don't need HTTP 2. Now here is the interesting part. VNet 1. I chose my virtual network where I am going to deploy my application gateway. And you can see here subnet gateway, it's automatically picks it up. But let's say if I chose this one. Now you can see subnet must only have application gateway. So if you recall, I told you like we need a dedicated subnet for creation of application gateway. So here you can see subnet 1. If I'm choosing it, then it is giving me the error because in subnet 1 I have deployed 2 virtual machines already. So it is not accepting this subnet as a right subnet. So let's go and choose this application gateway subnet, and right now you can see no error is there. Hit on next. Okay, so here is the settings or the configurations related to the front end. So we have just seen in application gateway, we have front end IP address. So we are going to use the public IP address. If I have option to use the private IP address, I can put it here as well, or I can put both as well. So for this lab, let's go with the public IP address. We already have created our public IP address. I'm just going to select this one, and this configuration is complete here. Now let's move to the backend. So here it is going to ask us which backend pool we are going to use because we need to add it. So let's create 2 backend pool. So I'm just going to creating image backend pool. And for my image backend pool, I'm going to use my image virtual machine. Hit on add. Let's add another backend pool, which I'm going to call it video backend pool. And for that, I'm also going to use virtual machine, and I'm going to choose video virtual machine. Hit on add. So this backend configuration is also done. Hit on next. So we are done with our front end. We are done with our backend. Now the routing rules. So routing rules, if you recall that image we told about, like in routing rules, we need to decide or we need to define the HTTP or backend settings and backend targets. So let's have a look into this. So it's the rule name. So it's quite simple. Put rule 1. Then priority could be anything. So let's put it 1. Now you can see the first section talks about listener. So listener is our logical entity, which is basically going to receive the request, all incoming request. And listener is going to use the public IP address or the front end public IP address over the port 80. And we don't need to do anything here. Let's go to backend targets. And here again, it is asking us to target type backend pool. So backend pool is image backend pool, which we are going to use. So this backend target is our default backend, which means anybody is going to access my application gateway, then first it is going to use this image backend pool. And the backup backend setting, since we do not have any backend setting, so we need to create one. So I can call it like my app HTTP setting or backend setting. We can call it both and keep it 80. In this setting, we are telling the application gateway to contact my backend server over port 80 by using HTTP protocol. So hit on just add. Now, the critical part here is the path-based rules. So let's say if I would like, as I told you, like I would like to access my application based on the URL. So let's say if I'm in my URL, I would like to put /video/my videos app or /image/my image app. Then it should open the relevant page. Then that configuration needs to be done here. So let's create a path-based routing here. You can see the target type is backend pool. First thing I need to create a path. So images /*. Target name, I can make it anything. I can put it like images. Backend setting, I can use the same backend setting. And now it is asking to which backend target you would like to use for your /images. So I can put it like /images and you can see image backend pool. Hit on add. Similarly, I'm going to do the same configuration for my videos. Here, target name, I can keep it videos, backend setting the same one, and this time I'm going to choose video backend. Hit on add. So this configuration also completes. Now hit on add. Hit on next. And review and create. So we have done all configurations related to my application gateway. and it is doing or running the validation. You can see the validation is passed. So let's go and hit on create. So this creation of the application gateway is going to take somewhere around 10 to 15 minutes. We need to wait for that, and then we will resume this session. So let's wait for this deployment which is in progress to complete, and we'll start after that. Okay, so it took somewhere around 10 minutes to complete the deployment. So our application gateway is deployed. So let's go to home, into the application gateway, and this is my application gateway, and here is the public IP of the application gateway. So let's copy this public IP of the application gateway and open a new incognito browser. Paste here, and you can see it's basically loading the default page, which is fine. Now if I am going to use my path, which is, let's say, images/my-app-images.html. You can see I used the public IP address of my application gateway, and I define the path here, and it's basically redirects to my image virtual machine or image app where I have hosted. Let's do the same thing with the video and validate it also. Here, we need to first remove this URL here and use the same public IP address, videos/my-app-videos.html. And this is opening my video app. So we have seen how this image web app and video web app, both URLs are working only with one IP address or one public IP address, which is of my application gateway public IP address. So this is how it works. Let's go inside the application gateway and explore some settings. You see here, first setting which we need to see is the front-end IP address. So click on the front-end IP address, and you can see it's the public, it's configured, and this is the front-end IP address. So this is where basically all the request comes. Now let's go choose the listeners and validate it also. We have our listener, and in this listener you can see we have port 80, and this listener is associated with rule 1, which means whatever traffic which is being received by the listener 1, it should use the rule 1 to direct the traffic. So let's go to rules, and here we have rule 1. If I click on the rule 1, you can see this is my listener. So listeners use the rule to send the traffic to the backend. And if I'll go to the backend target, you can see this is my backend pool. Default backend pool is my image backend pool. And we have backend pool, image backend pool here, and video backend pool here based on the URL which we have just seen. We can also have a look here, which is the backend health. The backend health basically tells how our backend servers or backend virtual machines are doing. So this is just for the monitoring purpose. You can use it. It takes some time to load, but it will show you. You can see here my both backends are showing healthy. If there is a issue with any backend, then it is going to show us a problem here, or unhealthy, or unable to contact, something like that. But right now here our both backends are working fine. So that concludes the lab of application gateway. We have seen what is application gateway. We have also discussed how the traffic flows by using the application gateway. After that, we created application gateway, and we have accessed our application from the public IP address of the application gateway. We have also seen how the route based or URL based, or I could say path based routing works. When we use different /images and /videos, how it works. Now this concludes the application gateway session. Now it's time to have a look at key points to remember. So here are few key points which we need to remember in context of exams. The first point says application gateway has 4 tiers. namely standard, standard v2, WAF, and WAF v2. So we have also seen in our lab while we are creating the application gateway, we have seen all these 4 options. Now the standard v2 and WAF v2 provides the option for auto scaling. We have seen this as well. When we selected standard or WAF only tier, then auto scaling option was disappeared. So only standard v2 and WAF v2 provides the option for auto scaling. The next point is application gateways with a tier of standard v2 and WAF v2 do not support only private address as the front end, which means if I would like to use private address at the front end, only private address at the front end, I cannot use a standard v2 and WAF v2. I must need to use standard or WAF only. So that is also a key point to remember. Next point says WAF or web application firewall provides extra layer of security to applications. Yes, this is the addition into the Azure Application Gateway where we can enable web application firewall. It provides us an extra layer of security to all the applications which is behind the application gateway and hosted inside the backend pool. The application gateway supports HTTP, HTTPS and HTTP protocols, 2 protocols as well. These are the 3 protocols basically supported by application gateway. Now an application gateway supports only one public address. Here we need to understand whenever we are going to create an application gateway, so we are going to find one component which is called front end. And inside the front end, we can only use one public address. Other than that component, we do not have any option to use public IP address inside the application gateway. Now, inside one subnet, we can deploy more than one application gateway. So this is also one of the prerequisite or a demand for deploying application gateway, like we need a dedicated subnet. So when we say a dedicated subnet for application gateway, in that means that subnet can only be used to deploy application gateways. So basically in that dedicated subnet, I can deploy more than one application gateway. It depends on the IP's availability, but I cannot deploy any other resources like virtual machine or virtual machine scale set or any other Azure services or resources. So these are the key points to remember for the exam preparations. Now let's go to the next section where we are going to review some questions and understand them in details. Let's move on. So here we are going to have our first question. It says you have an Azure subscription that contains a virtual network named VNet1 and the virtual machine shows in the following table. So we have VNet1 and inside VNet1 we have VM1, VM2 and VM3. And VM1 is hosting HTTPS application protocol, VM2 is SMTP and VM3 is SFTP. Okay. All the virtual machines are connected to VNet1. That's fine. Now, the next part of the question says you need to ensure that application hosted on the virtual machines can be accessed from the internet. Okay. And the solution must ensure that the virtual machines share a single public IP address. What should you use? We all know if we choose to use application gateway, then we can use the single IP address to access different applications. And we also have option to use path-based routing or URL-based routing. So if I look at the options, virtual network peering, Azure Application Gateway, NAT Gateway, and internal load balancer. If you look at all these 4 options, then none of these options will tell you how to use a single IP address except Azure Application Gateway. Our answers should be Azure Application Gateway. Azure Application Gateway is we can use to share a single public IP address to access different applications behind the Azure Application Gateway. Let's move to the next question. You have an application named App1 that listens for incoming requests on a pre-configured group of 50 TCP ports and UDP ports. Okay, so basically it says we have one application and its name is App1, and App1 is listening incoming requests. Fine, and it has pre-configured group of 50 TCP ports. Okay, the next part of the question says you install App1 on 10 virtual machines. Okay, so we have 10 virtual machines where we have installed App1. Now you need to implement load balancing for App1. That's fine, across all the virtual machines. So basically here we need a solution which can load balance the traffic across all my 10 virtual machines. And then it says the solution must minimize the number of load balancing. Okay, the question says we have 10 virtual machines. Inside those 10 virtual machines, we have installed one application which is called App1. Now 50 different TCP ports incoming request means multiple requests are going to come. Okay, and we have to design a solution. Let's look at the options here. Azure Application Gateway v2 that has multiple listeners. Azure Standard Load Balancer that has floating IP enabled. Azure Standard Load Balancer that has high availability ports enabled. Azure Application Gateway v2 that has one listener. So by looking at these options, one part is clear, like we are going to use Azure Application Gateway. Now option A and option D says Application Gateway v2 which has multiple listeners and Application Gateway v2 which has one listener. So by looking at the questions, we know the multiple requests are going to come. So we need multiple listeners to listen those requests. So it makes the sense that answer should be Azure Application Gateway v2 that has multiple listeners. Let's have a look. Yes, this is our answer. I hope this explains the question. Let's move to the next one. In question number 3, we can see you plan to implement an Azure Application Gateway that have the following configurations. Okay, it has public endpoint which is 1, it has one private endpoint, minimum instances are 1 and the maximum instances are 10. Fine. Now you need to configure the address space for the subnet of the application gateway. Okay, the solution must minimize the number of IP addresses allocated to the gateway subnet. So what is the minimum number of assignable IP address required? Okay, so let's look at the question at the very first view. So we can see we have one public endpoint, we have one private endpoint, so which means we need 2 IP address. Now the minimum instance is 1 and maximum instance is 10. So maximum we need here 10 IP address. So if you calculate 10, 1 and 1, then it should become 12 IP address. But here is the trick. You need to read the question one more time. Read the second part of the question. It says you need to configure the address space for the subnet of the application gateway. So here we need to understand we are talking about the subnet. And if you look at the above options, then out of 12 IP addresses, we have one public endpoint, which means that public endpoint is going to use public IP address. And public IP address cannot be a part of a subnet. So basically, we are going to need one less IP, which is 11. So if you calculate all the endpoints, then we needed 12, but out of 12 endpoints, we have one public endpoint when we are going to use the public IP address. So let's remove one and then answer becomes 11. So that's a tricky question to understand. So let's look at the answer. Yes, 11 is the correct answer here. I hope I explained these questions. Let's move to the next question. Here in our question 4, you have an application gateway named AZ-700, fine, that has routing rule named rule 1. We have seen in our lab as well, we have created application gateway and then created a rule 1 as well. Okay. Now the rule 1 directs traffic for www.contoso.com to a backend pool named pool 1. Okay, that's interesting. So basically rule 1 has the option to direct the traffic from www.contoso.com to pool 1. Now, pool 1 targets an Azure Virtual Machine scale set named VMSS1. And you deploy another virtual machine scale set named VMSS2. So let's understand this part. We have one application gateway. Inside that application gateway, we have one rule. And we have one backend pool called pool 1. And pool 1 is using virtual machine scale set 1 as its target. Fine. We also created another pool, virtual machine scale set, which is virtual machine scale set 2, VMSS2. Now you need to configure the same application gateway and direct all traffic from www.adatem.com to virtual machine scale set 2. So contoso.com traffic should go to pool 1 and pool 1 has VMSS1. Now the adatem.com should go to VMSS2. So what we need to create here? The first thing which comes to my mind is like we need to create a pool, a separate pool for VMSS2 where my www.adatem.com traffic will route. The first thing I'm going to create here is a pool which comes to my mind. Okay, so let's say we created a backend pool and inside that backend pool we have those virtual machine scale set 2. That's fine. Now, do we need to create any more? Let's see what are the options. Add a backend pool. Yes, backend pool is definitely the option. Modify an HTTP setting, add an HTTP setting, add a listener and add a rule. Okay. So when we have request like adatem.com and we have decided our backend pool, which is pool 2, and inside pool 2, we are going to deploy VMSS2. Then what else we need? So we need a rule, because rule is the place where basically we are going to define which one is my backend target and which one is my listener and which one is my HTTP settings. So basically the second thing which is going to need is rule. We are also going to have a rule. Absolutely. After that, we need a listener. Why? Because we would like to listen adatem.com on a different listener, because contoso.com must be used by the other listeners. So we need a listener as well. Out of these 5 options, we need a backend pool, we need a listener, and we need a rule. Let's see. Yes, these are the 3 answers and these are the correct answers. Now let's move to the next question. Okay. In this question, we have a statement. In WAF v2 and standard v2, application gateway can run only in fixed capacity mode, not in auto scaling enabled mode. Okay, that's pretty easy to answer because WAF v2 and standard v2 is providing us a auto scaling. So auto scaling is an option which we get with WAF v2 and standard v2. That is simply the false, because we do not have the option to run in fixed capacity mode with WAF v2 and standard v2. Let's have a look. Yes, this is our correct answer. Let's move to the next question. You have 5 VMs that run on Windows Server. Each virtual machine hosts a different web app. Okay, so 5 virtual machine and all 5 virtual machines has a different web app. Good. You plan to use Azure Application Gateway to provide access to each web app. Okay, by using host name and a different URL path for each web app. For example, contoso.com/app1. Okay, that's pretty clear. We are going to have 5 virtual machines. In all 5 virtual machines, we are going to have 5 different applications. And we are going to use Azure Application Gateway, and we are also going to use URL based routing. So application 1 should be accessible from contoso.com/app1. Application 2 should be contoso.com/app2, and similarly it goes till app 5. Okay, now you need to control the flow of the traffic. based on the URL path. What should you configure? HTTP settings, listener, rules, and rewrites. So in our example also we have controlled two paths of the same application, images and videos. And where we define that part? Inside the rules. Inside the rule, we are going to get the option to define our backend targets, and just beneath the backend target, we have the option to define the path. So let's say, yes, the rules is the correct option to use or to control the traffic based on the URL path. Let's move to the next question. Now you want to set up a virtual network on Azure. Okay, the subnet must be designed. Yes. Which two categories of resources demand their own subnet? Each accurate response offers an entire resolution. Okay, that's pretty much clear and easy question. We have virtual network we need to set up, and we also need to design our subnets. So now it is asking which one is going to require a dedicated subnet. App services, virtual network gateway, private endpoints, and Azure Application Gateway. So we all know Azure Application Gateway is going to require a dedicated subnet. Let's go to check other options. App services, nope, and private endpoints, no. Yes, virtual network gateway should be the another answer which requires a dedicated subnet as well. We have seen like gateway subnet is the one which we need to create when we have to deploy virtual network gateway. So now let's look at the answer. Yes, we have this answer. So this is the correct answer. Now that brings us to the end of the question review session. In the next stage, we are going to see, and thank you for attending today's class at 591 Lab. So we hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any question or concerns, please do not hesitate to contact us. We appreciate your participation and look forward to see you in our future classes. Before signing off, one more time, we have our humble request. Please like the video, subscribe the channel, hit the notification bell. Have a great day. Thank you.